For more than a century, we have been taught a simple story. The Earth changes slowly, mountains rise gradually, continents drift patiently, and climate shifts over immense spans of time. The present, we are told, is the key to the past. Small causes, small changes, vast ages. This philosophy, known as Uniformitarianism, became the foundation of modern geology and much of modern cosmology. Catastrophes were pushed to the margins. Global disasters became relics of mythology. Ancient traditions were dismissed as superstition. The gods never walked the skies. The heavens never changed. Nothing dramatic happened within human memory, or so we were told. But what if the evidence says otherwise? Quote, "The present is the key to the past," end quote, Sir Charles Lyell. Deep ice cores are among the most important climate archives on Earth. Researchers have long used electrical conductivity measurements to identify acidic layers within them, including those left by major volcanic eruptions. Yet comparisons between two of Greenland's best studied ice cores revealed significant discrepancies in their deepest sections. The authors concluded that ice flow may have introduced discontinuities into the record, and that further work was needed before reliable climatic information could be extracted from the oldest ice. If the deepest sections of these ice cores are more disturbed than often assumed, an obvious question follows. Just how secure is the chronology built upon them? One example concerns the eruption of Toba. Around 74,000 years ago, the Toba super-eruption was one of the largest volcanic events known. It blasted enormous quantities of ash and sulfur into the atmosphere. An event of that magnitude should have left a clear fingerprint within the world's great ice cores. Yet identifying that fingerprint has proved surprisingly difficult. Researchers have proposed several candidate signals, and only recently has one emerged as the leading contender. Correlating major volcanic eruptions with the deepest sections of the Greenland and Antarctic ice cores remains a significant scientific challenge. As Michael Steinbach quipped at the 2013 Electric Universe conference, quote, "I would like to start a charity for missing volcanoes," end quote. The remark was humorous, but it highlights a serious point. If even one of the largest known eruptions is difficult to identify with confidence, how certain can we be about the chronology of the oldest ice? The chemistry is not the only puzzle. Deep within several Antarctic ice cores, researchers have identified abrupt changes in crystal structure and alignment that are not always easy to reconcile with simple, gradual accumulation. Rather than changing smoothly through time, some of the deepest ice preserves remarkably ordered internal structures. Whether these features reflect pressure, chemistry, or something more unusual remains a matter of debate, but they serve as another reminder that the oldest ice may still have stories to tell. This leads to a provocative possibility. What if the deepest ice does not represent hundreds of thousands of years? What if the chronology is compressed? Could events interpreted as separate climate cycles actually be phases of a much shorter catastrophe sequence? The idea sounds radical, yet it raises important questions. How often have scientists mistaken duration for repetition, and how often has one event been interpreted as many? Quote, "No vestige of a beginning, no prospect of an end," close quote, James Hutton. The conventional timeline rests upon a number of assumptions that deserve continued scrutiny. Whether one accepts that conclusion or not, the challenge deserves attention. Catastrophism is making a comeback. For much of the 20th century, catastrophism was considered scientific heresy. Today, it is becoming increasingly difficult to ignore. The evidence continues to grow. Abrupt climate change, sudden extinctions, and rapid environmental transformation. Consider just a few examples. The Younger Dryas, megafaunal extinctions, ancient impact evidence, massive floods and abrupt temperature shifts. The picture emerging is not one of perfect stability, it is a picture of disruption, again and again. Even mainstream researchers now acknowledge that Earth can change dramatically over surprisingly short periods. Catastrophism is back on the menu. The debate is no longer whether catastrophes occurred, it is how many, how severe, and what caused them. Decades later, the once ridiculed geologist J. Harlan Bretz reflected, quote, "All my enemies are dead, so I no longer have anyone to gloat over." End quote. For decades, researchers exploring the electric universe model have proposed something even more controversial. Perhaps Earth was not the only participant. Consider the possibilities: an unstable solar system, planets in different orbits, close interactions between worlds, and events impossible under conventional assumptions. Quote, "The Earth lives in a cosmic shooting gallery," end quote, Victor Klub. The suggestion remains disputed, yet it emerged from an unusual observation. Ancient cultures around the world preserved remarkably similar traditions. They spoke of cosmic battles, wandering stars, gods fighting in the heavens, and worlds brought to ruin. Were these merely myths or distorted memories of extraordinary celestial events? The electric universe takes this idea a step further than the generally more conservative plasma cosmology perspective. It argues that mythology deserves closer attention, not because myths constitute scientific evidence, but because they may preserve clues to real events. Quote, "The historical memory of mankind is filled with descriptions of cosmic catastrophes," end quote, Immanuel Velikovsky. One of the most intriguing mysteries concerns Saturn. For many years it was regarded as little more than another gas giant. Then came a series of surprises. Researchers discovered unexpected similarities between the isotopic signatures of water found on Earth and those measured within Saturn's rings and icy satellites. In particular, the isotopic ratios of water appear strikingly similar, an unexpected finding that raises profound questions about our planet's early history. Could Earth once have been associated more closely with Saturn, perhaps even as a former satellite within a very different celestial arrangement? Ancient traditions seem to hint at such possibilities. The Atlantic Ocean, for example, was once known in classical sources as the Sea of Kronos, a curious echo of Saturn's ancient Greek name. As one report from phys.org, December 2018 explained, quote, "By developing a new method for measuring isotopic ratios of water and carbon dioxide remotely, scientists have found that the water in Saturn's rings and satellites is unexpectedly like the water on Earth." End quote. The same report concluded, quote, "The results also mean we need to change models of the formation of the solar system because the new results are in conflict with existing models." End quote. The findings challenged established ideas about the distribution of planetary materials throughout the solar system. While they do not demonstrate planetary rearrangement, they suggest that our models of solar system formation may still be incomplete. Within the electric universe movement, Saturn occupies a unique place because ancient traditions repeatedly elevated it above all other celestial bodies. The Roman Saturn, the Greek Kronos, the Persian Yima, and the Chinese genie of the pivot. Why did so many civilizations, separated by oceans and millennia, grant Saturn such extraordinary significance? Why did they so often place it at the center of their cosmology? As David Talbot observed in the Saturn myth, quote, "Chinese astronomers designated the celestial pole as the pivot, identifying the genie of the pivot as the planet Saturn." End quote. The question remains unanswered, but it refuses to disappear. Conventional astronomy rejects the idea that planetary orbits could have changed significantly within human history. Yet celestial mechanics has long wrestled with a fundamental difficulty known as the free body problem. While the gravitational interaction between two bodies can be solved exactly, introducing a third body produces behavior that quickly becomes extremely complex and, in many cases, chaotic. Despite giant leaps in computational power, mathematicians still have no general analytical solution for arbitrary free-body systems. This does not directly imply that the planets have recently wandered through the solar system, but it does remind us that long-term orbital evolution is far from a solved problem. If major orbital rearrangements were ever to occur, the consequences would be catastrophic. Is that what the ancients were trying to tell us? Plato suggested that the myth of Phaeton preserved the memory of a genuine celestial event. Quote, "It really signifies a declination of the bodies moving in the heavens around the earth, and a great conflagration of things upon the earth." End quote. His student Aristotle wrote, quote, "A tradition has been handed down by the ancient thinkers of very early times, to the effect that these heavenly bodies are gods. The rest of the tradition has been added later in a mythological form to influence the vulgar." End quote. Whether these traditions preserve memories of real astronomical events or simply express symbolic truths remains open to debate. Yet they remind us that the ancient world may have preserved observations of the heavens in ways that modern readers have too readily dismissed. Perhaps the greatest challenge to gradualism comes from the end of the Ice Age. Something dramatic happened. The climate shifted abruptly, ecosystems changed, large animals vanished, and human societies transformed. Conventional explanations continue to evolve. Comets, impacts, volcanism, ocean circulation changes, and solar effects. No single explanation satisfies everyone. What is clear is that the transition was anything but gentle. The Earth system appears capable of dramatic reorganization, sometimes with astonishing speed. The ice core analysis raises another uncomfortable question. If vast spans of time truly passed, where is the evidence of continuous human development? Many sites appear strangely static, cultures emerge, remain remarkably stable, then disappear. Even more puzzling, caves often resemble emergency refuges rather than permanent homes. The expected accumulation of thousands upon thousands of generations is frequently less obvious than textbooks imply. Again, this does not prove compressed chronology, but it raises questions worth asking, and science advances through questions, not consensus. Quote, "There have been and will be again many destructions of mankind." End quote. Plato. Imagine for a moment that ancient people witnessed extraordinary celestial events. Climate changed rapidly, the skies looked different, and entire populations were wiped out or displaced. What would survive? Not scientific papers, not observatories, not climate datasets, but stories, legends, myths, symbols, rituals, and religions. Memories carried from generation to generation. Over centuries, literal events would become sacred narratives. History would become mythology, yet fragments of truth might remain. Whether these interpretations ultimately withstand scrutiny remains to be seen. That is how science progresses. Claims must be tested, assumptions challenged, and alternative explanations considered. Laboratory studies have shown that electrical fields can influence the way ice forms, while studies of deep Antarctic ice have revealed highly organized crystal fabrics and sea-axis orientations. Such remarkable degrees of alignment are consistent with the possibility that electrical processes may have played a more significant role in shaping the deepest ice than is generally assumed. Together, these findings suggest that the oldest ice may be far more complex than a simple annual record of snowfall. One thing, however, is becoming increasingly difficult to ignore. The comfortable picture of a slow, uneventful past is giving way to one marked by repeated disruption, abrupt climate shifts, sudden extinctions, and rapid environmental change. Perhaps the ice is preserving more than climate. Perhaps it is preserving the fingerprints of catastrophic events that unfolded far more rapidly than we have imagined. The real question is not whether one ice core is correct. The real question is whether we have underestimated the role of catastrophe in shaping our world. The earth beneath our feet may be younger in some respects than we imagine. The skies above us may have been more dynamic than we assume. Ancient traditions may preserve more truth than we allow, and the past may be far stranger than the textbooks suggest. If so, the greatest scientific revolution of the coming decades may not concern distant galaxies. It may concern our own forgotten history. A history written not only in stone, not only in myth, but frozen deep within the ice itself.